Right now, somewhere out there, something might be looking back at you. Not a metaphor, not a theory, a real scientific possibility that most people never think about. And once you hear it, you won't be able to stop thinking about it either. We spend billions trying to find aliens. But what if we've been asking the wrong question the whole time? I'm FactSpark. If this is your first time here, smash that subscribe button. We explain the universe with bad drawings and good science. Let's go. We've been pointing our biggest telescopes at the sky for decades, scanning for signals, hunting for radio waves, sending messages into the void, hoping someone writes back. Nothing. Silence. The universe, apparently, does not reply. But here's the question that should be keeping you up at night. What if the aliens aren't lost? What if they've already found us, and they're just watching? To figure out how exposed we actually are, we need to think about this from the other side. Forget about us trying to find them. How would they find us? What would they see? What would give us away? Because here's the thing, we might be a lot louder than we think. Let's start with the most basic question. Could aliens even know Earth exists? 30 years ago, we didn't know whether other stars had planets at all. Then we started finding them. Then we couldn't stop. Today, we've confirmed over 6,000 exoplanets, worlds orbiting other suns, and the number keeps climbing every year. We've measured their sizes, their masses, how fast they orbit, how far they sit from their stars. And from all of that, we've identified a handful of rocky worlds sitting in what's called the habitable zone, the sweet spot where liquid water could exist on the surface. Not guaranteed to have life.
But the conditions aren't insane. Now, flip it. If we can do that, a civilization somewhere out there with roughly our level of technology could be doing the exact same thing, and Earth would be on their list. But here's where it gets interesting, and I genuinely want to know what you think about this. Drop it in the comments. If an alien civilization detected Earth tomorrow, do you think they would try to make contact, or would they go quiet and just keep watching? Think about it while we keep going, because the answer might depend on exactly how much they'd already know about us. The most common method we use to find exoplanets is called the transit method. Almost 3/4 of every planet we've ever discovered came from this technique. The idea is beautifully simple. When a planet passes in front of its star, it blocks a tiny fraction of the light. We measure that dip. We detect the planet. But to see that dip, you have to be lined up correctly. You need to be sitting more or less in the same flat plane the planet orbits in. And for a small, distant world like Earth, the odds of any given star being in that position are roughly 0.5%. Low, but not zero. A study found that among all the stars within about 330 light years of us, around 2,000 of them could have seen Earth transit the sun at some point in the last 5,000 years, or will be able to in the next 5,000. And in 7 of those systems, we already know there are planets. Some of them potentially habitable, like 2 worlds orbiting a star called Teegarden Star, just 12.5 light years away. From there, Earth's transit becomes visible in just a couple of decades.
There's also the radial velocity method, detecting the tiny gravitational wobble a planet induces in its star as it orbits. For Earth and the Sun, that wobble is about 9 centimeters per second. Tiny. But our best instruments are starting to get close to that sensitivity. So an alien civilization with technology roughly like ours, they might already have us on a list of interesting worlds worth watching more carefully. Okay, so let's say they found us. They know a rocky planet orbits our sun at a promising distance. Interesting, but not conclusive. What would they do next? This is where things get genuinely fascinating and genuinely uncomfortable. The transit method doesn't just tell you a planet exists. If you're patient and precise enough, you can use it to analyze the planet's atmosphere. Here's how. When a planet passes in front of its star, a tiny sliver of starlight filters through the edges of the atmosphere.
Different molecules in that atmosphere absorb different colors of light. So if you compare the light spectrum during a transit with the light when the planet is elsewhere, you can figure out what the atmosphere is made of. And certain combinations of molecules are almost impossible to explain without life. We call these biosignatures. On Earth, the obvious one is oxygen. Plants and phytoplankton pump it out constantly through photosynthesis. There's also ozone, potentially even easier to detect. Methane, nitrous oxide, yes, laughing gas, produced by microorganisms in soil and water. None of these alone is a smoking gun. Each could theoretically have a non-biological explanation. What scientists actually look for are disequilibria, combinations of molecules that shouldn't coexist. Oxygen and methane, for example. These two react with each other.
Left alone, methane would disappear from Earth's atmosphere in about 10 years. The only reason it's still there is because life keeps producing it. If you see both at once, that's a red flag that something biological is actively maintaining them. Another suspicious combo: nitrogen, oxygen, and liquid surface water simultaneously. Or, if we're talking about ancient Earth, methane and carbon dioxide with no carbon monoxide. These aren't random, they're signals. And then there's something even more subtle: seasonal variation. In the northern hemisphere, trees lose their leaves in winter. Plants stop absorbing carbon dioxide. The decomposition of organic material releases it. As a result, Earth's atmospheric carbon dioxide concentration fluctuates in a rhythmic, predictable annual cycle. With extraordinary luck and instruments, an alien civilization might pick that up too. Now, realistically, catching all of this via transit observations is brutally hard. You need to be geometrically aligned. Earth blocks a minuscule fraction of the sun's light. Characterizing our atmosphere properly might require observing hundreds of transits, and Earth only produces one per year. So transit analysis alone? Painful. Possible, but painful. There's another option: direct imaging. Instead of analyzing light that passes through the atmosphere, you actually take a photograph of the planet. You see the light it reflects, the same way we see the moon. The problem is that exoplanets are almost invisible next to their host stars. The star is blinding. To photograph the planet, you need to block out the star entirely, using a specialized coronagraph inside the telescope or even a separate structure floating in space nearby called a starshade. And even then, we've only managed to photograph planets that are large, hot, and far from their stars, not Earth-like worlds. That could change. Telescopes like NASA's proposed Habitable Worlds Observatory or the ESA's LIFE mission could, within 20 to 30 years, take direct images of Earth-like planets. They're still on the drawing board, but they're coming. If an alien civilization has already built something like that, direct imaging gives them a whole new toolkit. They could analyze reflected light from the surface itself. They might spot something called the red edge of vegetation, a sharp jump in reflectivity that happens when you shift from visible light into the near-infrared. Plants absorb visible light for photosynthesis and reflect infrared light they can't use. This creates a very specific optical signature. Unusual. Hard to explain without life. They might even map our continents and oceans from differences in reflected light. Maybe detect heat islands, cities warmer than surrounding areas. Some researchers have even proposed using a star's gravitational lensing effect as a natural telescope, powerful enough to image a planet's surface in detail. You'd need to send a probe to the outer edges of your solar system to pull it off. Science fiction for us, but a more advanced civilization? Maybe not. Here's where it gets loud. Really loud. Everything we've talked about so far requires aliens to be looking in exactly the right direction, with exactly the right equipment, at exactly the right time. Passive detection. Catching whispers. But we're not just whispering. Radio waves are one of the most detectable signatures a civilization can produce. Unlike light, they travel enormous distances without being absorbed by interstellar gas and dust.
Yes, they fade with the square of the distance. Double the distance, you get 1/4 the signal. But if they're powerful enough, they carry extraordinarily far. A recent study found that certain radio emissions from Earth could theoretically be detected by a civilization with technology similar to ours from up to 12,000 light years away. The culprit? Planetary radar. These are the massive bursts of radio energy we shoot at asteroids to track them, figuring out their size, shape, rotation, trajectory, whether they're going to hit us. We used instruments like the Arecibo radio telescope for this regularly. These pulses are extraordinarily powerful and extremely narrowband, meaning their frequency is concentrated around a single tight value, almost nothing like natural astrophysical signals. If aliens caught one of these, they'd have very good reason to think it wasn't nature. There's also the Deep Space Communication Network NASA uses to talk to its spacecraft, Voyager, New Horizons, missions at the edge of the outer solar system. Less powerful than planetary radar, but potentially detectable by a nearby civilization with comparable technology. And then there's everything else we leak. Military radars, airport radars, television broadcasts from decades ago still expanding outward through space as a growing sphere of human noise. All of these signals share one key characteristic that distinguishes them from natural sources. They're modulated. They carry information. Their frequency, amplitude, or phase changes in structured, non-random ways to encode a message. If an alien civilization detected that structure, they'd know immediately they weren't looking at a pulsar or a magnetar. They'd be looking at a technological civilization.
The main challenge on their end is confirmation. These signals tend to be brief and highly directional. You might catch a flash and then nothing. You can't always be sure it wasn't interference. It's the same problem we had with what's known as the WOW signal, a powerful, structured radio detection from 1977 that matched exactly what we'd expect from an alien transmission. Never repeated, never confirmed. But our broader radio leakage, everyday communications, the 4G signals bouncing around our cities, that's less directional and constant. Weaker, yes, but a civilization within roughly 4 light years might be able to pick it up, which, by the way, includes Proxima Centauri, our nearest stellar neighbor, which happens to have a planet orbiting in the habitable zone. So, what does the full picture look like? Earth is not invisible. It's leaking in multiple directions simultaneously. Our atmosphere contains chemical combinations that don't occur naturally. Our vegetation has a distinct optical fingerprint. We broadcast structured radio signals continuously and have been doing so for about a century. Our most powerful radar pulses could theoretically be detected from across a significant fraction of the galaxy. Now, the question isn't just whether aliens could detect us. The question is whether they already have. The most powerful signals we've sent, planetary radar bursts, have only been traveling for about 60 years. That limits the zone of potential detection to a sphere 60 light years wide. Not huge, cosmically speaking, but there are a lot of stars in that bubble. Here's the unsettling part. Even if an alien civilization detected one of these signals and knew it was artificial, they'd probably know what direction it came from, but not exactly how far it traveled. They couldn't pinpoint which star, so they might send a signal back in that general direction, hoping we'd reply. And if we did, game over. We'd have handed them a precise return address. So this is your note to self from FactSpark. If you ever receive what looks like an alien signal, do not write back. Tell no one. Sit very still. The universe is almost certainly full of life. The numbers are just too big for it not to be. But the distances are also almost certainly too vast for contact to be anything other than a cosmic accident. The probability of two civilizations being close enough at the right time in their development with the right alignment to actually notice each other, it's incredibly small. And yet, here we are, a small, loud, chemically peculiar radio broadcasting planet orbiting an ordinary star, leaking signals in every direction and growing louder every decade. We are not hiding well. If something's out there and it's listening, it might already know we're here. The question that no government, no space agency, and no philosopher has a clean answer to is, what do we do if they decide to say hello? Do we answer? Do we go dark?
Do we have a choice? Subscribe to FactSpark if you want to keep going down these rabbit holes. We've got a lot more universe to get through, and something tells me we're just getting started.